Here we are, third video of objects and classes. On the first two videos, we skipped over the slides and went directly to the code. That was super important. Not going to apologize because it was valuable to just go right into it. Understand what are classes, understand what are the blueprints and the objects we create from those classes. Just it's easier really to see the code, to feel it, understand it. And what we're going to do now is almost like backpedal a little bit and just make sure that we've covered all of those examples and seen them in the slides along with some other nuances. But this is going to be super quick, and we're going to end with a really cool addition to that example we've already been working on. So this is going to feel like just a review because we've already covered this in code. So as we've seen, OOP involves the idea of programming using classes and using objects. What is a class? A class is that blueprint. A class can be a blueprint for so many different things. A blueprint we've seen for students, for employees, for people, for places, for things, for, I mentioned here, external entities and roles, or organizational units, or even occurrences. And once we've created that class, once we've created that blueprint, we can then construct objects of that blueprint. And these objects, they're also called instances. Those are synonyms, instance and object. We can create a specific instance of that blueprint, which is an object. So using the blueprint example, the blueprint is, the blueprint of the building, and the objects we created are the individual homes that we create from that blueprint. And the behavior of an object is specified by a set of methods that come from that blueprint as well. So I like here in red where it says an object is really a software bundle of variables as well as their related methods. So in summary, we have these two things. We have the blueprint, these classes that we are creating, and then we have objects that we will create from these classes, from these blueprints. And we've been making objects from day one. Scanner variable, random variable, strings. These are all coming from classes, from blueprints that Java has created for us. In fact, anytime you see this new keyword, that's a command. Yo, Java, make for me a new object from whatever class you are specifying. Now, what's going to be cool about this chapter, as we've already seen, is now we're moving beyond the built-in blueprints and classes that Java has provided for us, and now we're going to make our own custom classes. We've seen student. Another example could be employee. Maybe you make an employee blueprint. What would that probably have? An ID, employee ID number, a first name, a last name, likely a social, maybe an address, certainly a salary or an hourly wage, and other components that would make up that skeleton, that template or that blueprint of an employee. And then you could make objects of that employee. So here's other examples. We've seen people, right? Student and employee. What about other things? Maybe you have an example class, could be a car blueprint. And then from that car blueprint, you can make specific car objects, such as a Ferrari. Or maybe you have department would be a blueprint. And then you can make specific department objects, a department of computer science, a department of information systems, and so on. So we can model these real world objects. It's not just people, but things or occurrences, the type of an alarm, a fire alarm. All of this can be modeled through this OOP paradigm of making these classes for these real world objects and entities, and then creating objects from those classes. So summarizing again, we've seen these standard classes, these built-in classes that Java provides for us, examples being scanner, random, string, and others. This is hugely important to understand the built-in classes, and learning to use the standard classes is really the first step towards mastering OOP, object-oriented programming. But along with that, that next big second step is now making our own custom user-defined classes. And this is really where the power begins and where it's so super cool to make custom defined classes. What is UML? In short, if I want to tell someone, make me a class to do such and such, I can give you a very long-winded description. I can show you some pseudocode, or I could just show you a UML diagram, and a developer would say, okay, I got you. I know what you want. So what is UML? It stands for Unified Modeling Language, and it's effectively a visual depiction of a given class. So a class UML diagram, it's really a rectangle divided into three components. The topmost component gives the name of the class, the middle component gives the data members, and then the bottom component lists out the various methods, whether those be constructors or other methods that are needed. So here's an example of a UML class diagram for a student class, for a student blueprint. We have the student name. We then have the data fields. In this case, it's a silly example. We only have one data member, a string, the name of the student. And then we have some methods, a get name method, as well as a set name method. Also in UML, we can depict the individual objects. So here's a student object called S1 with the name Jacob, another student called S3 with the name Ricardo. As we've seen, this is the overall template of what a class should look like. You may have an import statement if you need to import anything for your class. Maybe you need to, for some reason, to make a random number inside your class. So you would import java.util. You could put a wildcard import or import random. You might have some comments in your class. But in general, what is really going to be the skeleton or the template of your blueprint of your class? You're going to have a class name, you're going to have the data members, and you're going to have methods. And these methods will also include constructors. So here's an example class for a student. We have just a single data member, the name of the student, and then we have some methods. We have a set name method that receives a string as a parameter, and it saves that string into the student name, this data member name. And then we have a get method, which simply returns the name of that student. So let's look at declaring objects and then creating those objects. So here, just like a regular data type, we need to first declare the variable that's being created. So here I'm creating a student variable called Jan. So I need to put the data type. I need to say student Jan. That's the declaration. I could also say account customer, or vehicle, car 1, car 2, right? These are just declarations, but no objects have been created yet. Now I can create the object. I could say Jan equals new student. So here I need to specify the data type, the blueprint that I'm trying to tell Java to create an object from. And then within these parentheses, I need, pardon me, the power of pause. And then within those parentheses, I'm going to specify maybe 0 or more parameters, maybe no parameters, or maybe other parameters that will help me construct my object. Other examples, I could say customer equals new account, car equals new vehicle, and so on. So breaking down those two components of declaration versus creation, here we declare a variable S of type student, but S currently points to nothing. And now we check the next line of code. Now we create a new student object, and we save the address of that new student object into the variable S. Of course, you needn't declare on one line and then create the student object on the next line. You can do it completely in one go by saying student S equals new student. We've also seen that we can use the dot operator to access public members of our class. So if you make a new student, you can then access the first name and we can save Patterson, for example, into first name. We can save an ID number into the ID data member if that data member exists. So any of those public data members, if they're public, we can use this dot operator to directly access those public data members, as well as any public methods, such as s.getFirstName. It would retrieve for us the first name if we've created that method, or s.printStudentDetails would allow us to then invoke this method called printStudentDetails. So what follows is just some extra classes to look at. Here we have the student class. We're going to look at a bicycle class, and we're going to look at a couple others. So here we have a student class. We've made a new student. We've set the name to Mark because Mark is not private. We can directly, name is not private. We can directly save Mark into name, and then we simply printed it. We can also set name to Lindsay afterwards. So now we've only created one student. The name was Mark, but now we're actually invoking the set name method, and we're changing the name. We're updating the name from Mark to Lindsay, and then we print out the name of that student again. Here's another example. We have a bicycle class. This bicycle class, every bike has an owner, the owner of the bicycle. And we have these two methods, the get owner name and the set owner name. So there's the data member owner name, and here are the methods. From this class, we can create bicycle objects. We can make bike 1, we can make bike 2, and each of those bike objects, of course, would have individual owners. So here's the code. We have our bicycle class, we have our single data member owner name, and then we have two methods. Get owner name simply returns owner name, which is a string. And then we have set owner name, which receives name as a parameter, a string, and it saves or it assigns that string into the data member owner name. So with that now said, let's look at this example. We make two bicycle variables, bike 1 and bike 2. We make two string variables, owner 1 and owner 2. And now we make a new bicycle object, and we save the address of that object into bike 1. And then we invoke the set owner name method. We set the name of bike 1 to Adam Smith. We make a new bicycle object, which we save the address of into bike 2. And then we set the owner name of this bike to Ben Jones. Finally, just for the purpose of testing out the getter method, we want to print those two owners. So look at this line of code on the right side of the assignment. I say bike1 dot get owner name. That will get me the owner name of bike 1, which will be Adam Smith, because bike 1 points to this bicycle, and we set the name to owner Smith. And then owner 2 is bike 2 dot get owner name, which is going to be Ben Jones, and then we simply print those two values. A review of constructors. We've mentioned that objects are created whenever you use this operator new, this keyword new. But in fact, how are those objects created? They are created using constructors. Java uses a constructor to build or construct your objects. And a constructor really looks like a regular method. And it looks like a regular method, but it's not quite a method. It feels like a method. The difference is the constructor shares the same name as the class. Also, constructors have no return value, not even void, because they return nothing at all. A constructor can have no parameters, 1, 2, or many parameters. The values that we passed through these parameters can then be used to set or to initialize the data members of our objects. And that's really when you get the power of constructors. So constructors, they're really, think of it as a special kind of method that is used, that are invoked to construct our objects, and they're specifically invoked anytime you see the new operator. One more time, what's the purpose? The purpose of constructors are to construct our objects. They play the role of helping to initialize the objects that are being constructed. One more example, class circle. Super exciting class. This is the one from the textbook. I rather use student or employee. The textbook, for whatever reason, it uses circle. Double radius is the single data member. Here we have two constructors. We have an empty constructor with no parameter. We also have a second constructor that receives a double called newRadius, which we assign into the data member radius. And then finally, we have a method called getArea, which merely returns the area of this circle object, pi times radius squared, pi r squared. So default constructor, we've talked about. A class can be created without any explicit constructor given by the developer, by the programmer. However, Java requires the use of a constructor in order to build objects. So how do we reconcile that? That we say Java requires a constructor, but it could be the case that you, the developer, don't put a constructor. How do we reconcile that? What happens if you do not put a constructor, Java will automatically include for you, I say jokingly, free of charge, what is called the default no argument constructor. Java will provide this to you under the condition that you have not explicitly included any other constructor at all. That is the default constructor. So if you notice on this class circle, no constructor is given here because you don't see public circle with parentheses. So there's no constructor, which means what? Does that mean that Java cannot construct objects of type circle? No. What it means is that Java will include, free of charge, the default no argument constructor because there is no other constructor currently shown. Here we have a circle blueprint. This is the UML of our circle class. We have the two constructors shown. We have a getArea method. We have a getPerimeter method. And we see here that we have made 3 circle objects. Here's the code for a simple circle class, not circle, but simple circle. We have a data member radius. We have 2 constructors. This first constructor is a no argument constructor, and we're setting radius to 1. The second constructor, we receive 1 parameter newRadius that we assign into the data member radius. And then finally, we have 2 methods, getArea as well as getPerimeter. And here is some code. I can make a circle, a simple circle object called circle1, and then I can print out the area of the circle of radius, and I can print the radius and print the area. And here, since we've made a new circle on this exact line of code, we've made a new circle with no parameters. That means we're going to come to this constructor and radius is initialized to 1. So a circle, the area of a circle with radius 1 is pi r squared, pi times 1 times 1, which is going to be 3.14. And we simply make 2 other circles with a specific radius sent over to the constructor. So in this example, we send over 25 to the constructor, and 25 becomes newRadius, which gets saved into the variable radius. And then finally, we print out that information. And on this last line here, we simply update the radius of circle 2, demonstrating that we can update that data member value. What follows is just some visual depictions of that same thing. We make a new circle object. So here we have my circle, which currently points to nothing. But once we make a new circle object and we save its address into the myCircle variable, it now points to this new circle object. In that same way, your circle right here, this variable, currently points to nothing, but once we make a new circle object with this radius 1 and save its address inside your circle, it's now pointing to this new circle object, and we can update the radius. That's it. Now let's jump back over to code and see something super cool. Are we ready? I'm looking at the time. We're at 20 minutes. I want to spend no more than 10 minutes here. This is where we were last time. This is the OOP demo, and this was our student blueprint. We had 4 data members. We had 2 constructors. We made 4 getter methods, the accessor methods, and we made 4 setter methods. And we also made this extra method, print details. This was from last time. So what I want to do here is I want to just plant a seed of something really cool that we're going to elaborate more on another video. What if we wanted to include the following data members? Private string address 1, private string address 2, like line 1 and line 2. How about private string city, private string state, and then private string zip. I'll even make zip as a string in case you have a hyphen with some extra numbers. So imagine that we want to include all of these other data members. That's 5 more data members. Let's even get rid of address 2. Let's keep address 2. Those are 5 data members. So now we need 5 more getters and 5 more setters. This is going to be fun. Pause it and type it if you want. Public getter. These are all getters, right? So string get address 1, return address 1. I want to copy this. See if I can save time by pasting. This is address 2. And here, this is going to be city. Oh, this is supposed to be get. Get, capital C, city. And then return city. I think it's just easier to type at this point. Public string get state, return state. Public string zip get zip, return zip. Those are just the getters. Now we need to come make all the setters. Oh no, let's do that. It only takes a couple of minutes. So public setting, we're not returning anything. So public void set address 1, and we're sending over string address 1, and we're going to say this dot address 1 equals address 1. Hopefully we understand and remember the this from last time. Public void set address 2 string address 2. This dot address 2 equals address 2. Almost halfway there. Public void set city string city. This dot city equals city. And 2 more. Public void set state string state. This dot state equals state. And then finally 1 more. Public void set zip string zip. This dot zip equals zip. All right, we now have our getters and our setters. So let's come back. What if, let's make a new constructor though. So our constructor, we want to make another constructor where we send over all of those things. So here we have all 4. What if I say now all 9 data members? So now I need to send over string address 1, string address 2, string city, string state, and string zip. So I need to assign each one of those into their data members. No problem. This dot address 1 equals address 1. This dot address 2 equals address 2. This dot city equals city. This dot state equals state. Come on. And this dot zip equals zip. So what I could do, of course, from my main, I could make a new person, student S3 equals new student, 1113333, comma, let's make a new name. I got over here, I don't know what a new name. How about Bob? It's not very creative, but I see a last name, Kaufman. And Bob Kaufman has a 3.2 GPA. Bob Kaufman is, what is their address? Line 1. Their address is, they are at 111 Lake something Boulevard. And their line 2 address is apartment 101. They are in which city? New York. And their state is New York. And I don't know New York zip code. It is 98411. All right, we sent over 9 things to this student. And of course, we could then try to print this student. But currently, this print method is not going to print over. It's not going to print everything. It's only going to print those first 4 data members. I put here an integer. This needs to be as a string, 98411. So none of that's new. None of that's unique. None of that's cool. What is the cool thing that I want to plant the seed of? Well, let's think about this. Look at what we just did. I had these 4 data members. I included 5 more data members. Now, what are those data members? Address 1, address 2, city, state, zip. But what do they really collectively represent? You're like, oh, what do they represent? I don't know. Are you confused? No. What do they really represent? They collectively represent an address, which really leads us to maybe a big brain moment where we can realize, wait, can I? Should I? You can actually make a new blueprint, a new class just for address. And all of these things right here, you're really going to say something like this, address A. And what is address A? It's going to be a new blueprint we're going to make right now. So I'm going to take all of these 5 data members. I'm going to highlight them, Control X to cut them. I'm going to come over here to our package. I'm going to right click, new Java class, call this address, and I'm going to zoom in, delete the trash that I don't need, paste my 5 data members. Now I need my getters and my setters. Well, I already made them. So I'm going to come over to these getters and setters that I made. Let's come get all the getters. I'm going to cut them out, and let's type over here, getters, paste, and setters. Let's get those setters. Here are the 5 setters we made. Let's cut those out as well, and we paste those setters. Now we also need to have a constructor. So public, let's put a comment first. Constructors, public address. Let's put an empty, no argument constructor. And let's also put some other constructors. So public address. What if we send over all 5 parameters when we want to make a new address? So what I'm going to do is I want to take all of these 5 parameters that I had already typed up here. I'm going to paste them here inside this second constructor. And then here are those 5 lines of code that I had typed where I am initializing those data members of the address object. All right, so that's a lot. I want to back up. What did we do? We said, let's add an address, 5 data members to our student. But then after we did that, we realized, wait, that is really a self-contained thing. Every person has an address. So instead of putting all 5 data members here, we said, wait, let's go make an address object. Let's create, an address blueprint. Let's create this address class. And now that we've created this address class, check this out. Private address A. That I'm going to say that every student blueprint has not only these 4 data members, but every student blueprint also has this data member, a 5th data member called A. What is A? And I could have called it address if you like, ADD, but, or if I put address, it might be confusing because this is lowercase and this is uppercase, the name of the class. This is a variable. So I'll just call it address A. Well, what is A? It's going to be a reference that points to an address object that is going to be stored on the heap. So here's what actually happens. When we create a new student object, remember, all of the data members get initial values if we don't do anything else. So here, ID really becomes 0. You don't have to type that though. First name really becomes an empty string because it's a string. Last name also becomes an empty string. GPA becomes 0.0. But what about a referential data structure, such as an object? A actually becomes null, meaning there is no address object created yet. So how do we create any object? Whenever we want to create an object, we need new. So check this out. Now, what I'm saying is when you make a new student object, even using the default constructor, I can get rid of all these things. But when you make a new student object, here I'm saying make a new address object as well, and save that address object, or the address of that address object. That's kind of confusing maybe. Save the address of that address object into the variable A. And so I'm going to do the same thing here in this constructor. And here's what's really important in this constructor. And this is where it's like, maybe it'll blow our mind. Check this out. In our main program, remember, we made a new student with not 4 parameters, but 9 parameters. And we sent over these 5 components, these 5 parameters that are specific to the address object. Now look at what I'm going to do inside that constructor. Remember, I'm calling this constructor student the one that has 9 parameters. And here it is. Well, what am I going to do with the first 4 parameters? These first 4 parameters right here, I immediately save them into the data members. But what am I going to do with these other 5 parameters? Well, check this out. I'm going to effectively forward the other 5 parameters on to the constructor of address. So I'm going to basically come inside here, and I'm going to say, you know what, address 1, address 2, city, state, and zip. So inside the constructor of student, this is what's really funky the first time you see it. Remember, we're constructing a new student right here. And we come to that constructor, and we assign those first 4 parameters to the first 4 data members. But what about these other parameters? And what about the fact that this student object, in fact, has this variable A of type address? What does that do? Well, we're going to make a new address, and I could have made a new address with the default no argument constructor, the empty constructor right here. But since I had created this other constructor that expects 5 parameters, because of that, I said, you know what? Let's call that other constructor, and let's effectively just forward on these 5 parameters that were sent over. Let's forward them to the address constructor. So one more time. Here we're in the main class. We're in main. We create a new student object, and we send over 9 parameters to that student object. We take the first 4 parameters, and we save them into the 4 data members of student. The other 5 parameters, we forward them on to where? To the constructor of address. So now we're going to make a new address object, and we're going to save that address object into the variable A of this student. So check out what's actually happening here. So we've made a new student, and when I make this new student, we sent over 9 parameters, right? Well, here's this new student. I'm drawing a new object. What's inside here? We had the ID, we had the, what was it, name, it was really first name. We had the last name, right? This was equal, let's say it was equal to 0, equal to an empty string. This is equal to an empty string. We had GPA equal to 0.0, or better yet, if we come back and we look at that example, what did we specifically send over? We sent over, it was Bob Kaufman 3.2. Not a big deal, but we get the idea that this, fine, let's go fill that in. This would have been Bob. This would have been Kaufman. GPA 3.2. The ID was whatever it was. I don't know what it was. But the point is that when we make this new student object, and I come over here to the constructor of that student object, I just did those 4 lines of code, but what happens right here is what I want to draw. What happens right here is we have that variable A. Let me erase this. We have this variable A. A is an address that points to what? It points to an object that's being created, an address object. And what's going to be stored inside that address object? Let's go back and look at what we sent over with it. We sent over the 111 Lake something Boulevard, apartment 101, New York, New York. So we're going to send over, this is going to be this 111 Lake whatever Boulevard, apartment 101, the city was going to be New York, the state, NY, and then the zip. So the takeaway here that I want to show is that when we made this new student object and saved it into what? S3. S3 points over to this new student object. But in the process of creating that new student object, what else did we do? Is we created a new address object as well that got saved where? Right here inside A, which is a data member of student. This is super cool. The fact that we now have one object that we've created from main, but in fact, a data member of this student object is really just an address to another object. I wanted to plant that seed. This is just more of a trailer. We will cover that in more detail. We'll show how to print that information. We'll even edit this print method. It's going to be super easy to edit. We'll edit this print method, but we'll save that for another video. It has been super fun. As always, reach out, ask a question if you need anything. Take care.